Specific gravity is just given by SG for specific gravity. And the specific gravity is the ratio of the substance, the density of the substance you want to measure, or that you have measured, to that of water. And I'll use a subscript H2O to show that it's water. Now, notice that the mass density over another mass density, all the units are going to cancel. If this is grams per centimeter cubed, and this is grams per centimeter cubed, for example, they're going to cancel. So it's just a pure number, just a ratio. Now in this case, I've got 1.1 grams per centimeter cubed. That's Geordie's mass density. So the specific gravity is going to be 1.1 grams per centimeter cubed divided by the mass density of water. It just so happens that the mass density of water, it doesn't just so happen, they planned it this way, is exactly 1 gram per cubic centimeter. Makes it pretty easy in metric units. So 1.1 grams per centimeter cubed is the mass density of the object I want to get the specific gravity of. Mass density of water is 1.0 grams per centimeter cubed. The grams per centimeter cubed cancel. So Geordie's specific gravity, 1.1 over 1 is 1.1. That's the specific gravity. Now, there's another kind of density, right over here. In English units, we usually don't talk about the mass, we talk about the weight. And so we're concerned more with the weight density. How many pounds per cubic feet, for example, do we have, or how many pounds per gallon? So the weight density is, you might expect, here's weight density. Weight density is just weight per volume. And the units are going to be like pounds per cubic foot, pounds per gallon, and so on. Any kind of weight over any kind of volume. Let me do an example here. Let's say we've got let's say I've got a pile of something here. I'm not sure what that is. Maybe it's a fresh pie. And it's got a weight of 2 pounds. And it takes up a density of a quarter of a cubic foot. It takes up a volume, excuse me. So the volume is a quarter, 0.25 feet cubed. Well then, the weight density, which is what I want to know, can be solved with this equation. Let's see, I've got a picture, variable value unit. Okay, everything looks good. The weight density, here's my working equation, weight per volume, which is 2 pounds over 0.25 cubic feet, and that's going to be 8 pounds per cubic foot. Simple as that. Mass volume is how much mass I've got in a certain volume. Weight density is how much weight I've got in a certain volume. My weight's about 200 pounds, and I take up about 3 cubic feet of space. So my weight density is 200 pounds over 3 cubic feet. It's about 67 pounds per cubic foot. Let's see now. What should we do next? We should talk about, oh, let me finish off with specific gravity. I told you specific gravity is mass density over the mass density of water. Well, weight density is just mass density times gravity. Just like weight is mass times gravity. So if I divide one weight density by the other, I should get the same thing. So another relation for specific gravity is this. Specific gravity is also weight density over the weight density of water. Remember that the W stands for weight, not water. That's why I use the H2O. And again, you're going to have like pounds per cubic foot over pounds per cubic foot. So they'll cancel out. So specific gravity has no units. We generally measure specific gravity with an instrument called a hydrometer.